Hi, how are you guys? Sorry, my voice is still not great, but we're going to start in on section 10.5 today. So hopefully your inscribed angle 10.4 section went well. We're going to be kind of adding to those rules today. So for our objective, we're going to find measures of angles inside or outside circles. Okay. And again, I think we're good without a warm-up, so we're just going to hop right into the lesson. It says, recall the measure of a inscribed angle is half the measure of the intercepted arc. And then kind of going back, I will use this little warm-up area for a second. So basically up to now, we've studied two angles. The central angle, which is when you have a vertex at the center of the circle. This is the one people tend to forget about. Whatever this angle measure is identical to the arc measure. So don't forget about that one. And then the second one that we learned in our previous lesson was if you have a vertex on the circle, that this angle right here is half of the intercepted arc. So if this is 50, this would be 100. So the angle is half the arc. Here, when the vertex is at the center of the circle, they're equal. This is on the circle. So today we're going to be working on our last two big rules that are talking about when it's outside of the circle or inside of the circle. And the first thing we're going to actually start with is the tangent one, but this is going to be pretty similar to what we were doing the other day. So this theorem says if a tangent and a chord intersect at a point on a circle, so we're going back to on a circle, if a tangent and a chord, remember tangent hits the circle one time, then the measure of each angle formed is half the measure of the intercepted arc. So this is the same rule that we discussed before. So if like we're looking at angle 1 in this picture, it's just weird because the arc comes to at the vertex. So in this particular picture here, angle 1 would be half of arc BA. So from B to A, which is kind of weird. Notice that this circle is only split into two different arcs. It has this minor arc over here, and then it has this big major arc there. Don't forget that both of those added together always make 360. That's going to be pretty huge in this section of notes. So if you look at the first couple examples here, it says line M is tangent to the circle, which means it's touching the circle here at one point here. And it says that this value is 228. That obviously has to be this major arc out here. And so they want us to find the measure, the indicated measure of this angle here. So again, I don't know what's wrong with these sheets, if it's just how they're printing at my house, but this should say to find the measure of angle 1. So to find the measure of angle 1, I need to know this arc out here. I'm trying to get a different color, sorry. Okay, so I need to know this arc measure, and I can find that by taking 360 and taking off the 228. Okay, so if you do that, it's going to give you a value of 132 degrees. This arc then is 132. But to get that angle, remember the angle is half the arc, so half of the 132. So this angle, measure of angle 1, should be 66 degrees. That should be your final answer. Notice in this one, they are looking for an arc. So this is a little different. I'm going to go ahead and locate that arc on the paper. So E to F to D, this whole arc over here. All right, and notice right here is a vertex, and we know this angle measure right here. So if the angle is half the arc, in this particular situation, I know the angle is 110. And so if 110 is half of my arc, all I have to do is multiply both sides by 2. And I know the arc that I'm looking for is 220 degrees. So this one right here should be 220 degrees. Okay, again, kind of some messed up directions. Find the value of x given that the measure of angle MLK is 3x plus 22 degrees. So find the value of x given that the measure of angle, so this angle in here, is 3x plus 22. So obviously if I'm looking at this angle, I want to trace out and look at this intercepted arc, which would be here. And unfortunately, I don't have a value for this, but if you see the rest of the circle over here is 244 degrees, then to get this arc, I just have to take 360 minus that 244. And so, sorry, I'm trying not to cough on here. This is 6. This is 116 right here. Okay. So what do we know about this angle? Well, this angle, because the vertex is on the circle, the angle is half the arc. So we know that 3x plus 22 is equal to 1/2 of 116. So that would give me that 3x plus 22 is equal to 58. And then you subtract the 22, you get 3x is equal to 36. So x is 12. And for this particular problem, it did say find the value of x. Again, I apologize if what I attach is looking like this. I don't really know why that's happening. It could just be my printer, so hopefully you guys can just pay attention to that. Okay, that got us through our first theorem that was a lot like what we did yesterday. So this is where it's going to start to get a little different. I may even have a little surprise video for you. I don't know if you guys remember me telling you you were going to have to sing a song in this chapter. So now guess who gets to sing that song? Don't judge me, please. Okay, so next theorem. If two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So now notice, the key to all of these is where is the vertex? You're going to hear me probably say that so many times that you're going to get a little annoyed with me, okay? But here's the vertex. It's in the circle. It is not at the center, so we don't apply that rule. So if we're talking about angle 1, we need to know angle 1. Angle 1 is going to be half of the sum of the arc that's directly across from it here, which is arc DC, plus if you go to angle 1's vertical angle, which is right here, and you go out to the arc associated with that, that's AB. So you must remember the difference between these and the central angle. The central angle is also inside the circle, but it's at the center. So that's like a totally different circumstance. Okay. So again and again and again, pay attention. Where is the vertex of your angle? So for the next one, I should just say find the value of x. So what I see here is I see a vertex in this circle. So I know that this angle right here is equal to half the sum of my two intercepted arcs, which are going to be the 110 and the 60. So I know that 6x plus 19 is equal to half of, add your arcs together, 110 plus 60. And so 6x plus 19 is going to equal half of 170. If you want to just add those together and then divide by 2, obviously you could distribute that too, but that distribute the 1/2 is what I meant. But this is also easy to come up with 85. When you subtract the 19 over, you should get that 6x is equal to 66 and x is 11. Now be a little bit careful. Like if you were on any kind of standardized test, a lot of times they're not going to ask for x. They're going to ask for a particular angle or maybe even an arc if there's some variables there. So just be careful. So when the angle is when the vertex is inside the circle but not at the center, it's half the sum. So let's kind of go over the ones that we know. So the poor central angle is not going to make my song, okay? So for the central angle, the angle equals the arc. That's when the vertex is at the center of the circle, okay? If the vertex is on the circle, it's going to be angle is half the intercepted arc. On the circle, half the intercepted arc. If it's in the circle, it's going to be, the angle will be half of the sum of the two arcs that are intercepted. And now we just have one more to go. So I kind of put these in a box. So now we're going to do out. What happens, look at these pictures down here. Here's a vertex that's out. Here's a vertex that's out. There's a vertex that's out. And so these are three pretty different looking pictures. And so the rule for out, so if a tangent and a secant, or two tangents or two secants intersect outside a circle, so really you just pay attention to that vertex. If it's outside the circle, then the measure of the angle formed is half the difference of the two intercepted arcs. And when you're adding back up here, it doesn't really matter the order that you put these in, because we talk about addition all the time being commutative, meaning order. You can add 3 plus 2, 2 plus 3. It's going to give you the same thing. But down here, your order is going to matter, because 3 minus 2 and 2 minus 3 are not the same thing. So if you look at this first picture, here's the first arc that intercepts, and then here's the second one. Okay, and so basically we always want to put the bigger one first before we're subtracting. So if you look at this picture, here's the first, this big P all the way around to R, that's the second. If you notice, those two arcs take up this whole circle. And then on the last one, here's the first arc that's intercepted, and here's the second arc that is intercepted. So like for this one, angle 3 would be half of, now we got to take the bigger arc first, this one out here, arc XY minus arc WZ. So it's half the difference. So if we kind of come back up to our little chart, the angle will be half the difference. And the song that you may or may not hear shortly is going to be about on, in, and out. So you're just going to have to memorize that central angle one, which is the very first one we did. Okay. So for some examples, find the value of x. So in these, they just want us to find x. So I first want to establish, where is my vertex? Okay, it is out. So a lot of times on my paper, I'll even write down the word out, and then I'll write down angle is half the difference. It's just good to kind of have that in your head. So what is my angle in this case? Well, that would be the x there, right? So x is half the difference. So I have to subtract the two arcs that this intercepts. So we have a 72 and we have a 170. And again, you always want to put the larger one first. So 170, take away 72. So this x is going to become half of 98. And so this ends up being 49 for this particular problem. All right, on B, where's the vertex? Well, it's out, right? So this is the angle, and so our angle is half of our difference. Now, again, you're missing information here. Measure of angle C is equivalent to 7x minus 7. So this in here is 7x minus 7. So again, I'm going to write the words out. I'm going to write my angle is half my difference because I don't want to mess that up. So my angle, that's 7x minus 7, is half, and I'm going to use brackets. And the reason I'm going to use brackets here, if you notice, these are both binomials. So this math gets a tiny bit tricky. Okay. Sorry, I'm having problems holding my paper in my phone here to video for you. But this arc down here is bigger. So the 28x plus 5 goes first, but then you have to subtract, and you need parentheses there, 17x minus 5, because what are we going to have to do? Sorry, that kind of went crooked. What are we going to have to do with this negative sign, though? If you don't put the parentheses here, you will not distribute that correctly, and you will miss the problem, and that happens a lot. So, excuse me, sorry. So 7x minus 7 is equal to 1/2 of, it's 28x take away 17x. So that's going to be what, 11x. And then right here, you got to be really, really careful. When you distribute a negative to a negative back here, -1 times -5, you get a +5. So you already had a +5. Now you're going to get another +5. So this is going to get me to +10. Okay, so here's an example of when we have a half next to an odd number. Most people don't really like to do that. So at this point, we can just multiply both sides by 2 and call this 14x minus 14 equals 11x plus 10. We're able to move the 11x over, so this is 3x, and move the 14 over, so that's 24. I'm so sorry for coughing again. X is 8. So again, if I were in class today, I'd probably put that big annoying star on the board to show you, hey guys, this is the one people miss a lot because of right here, this distributing the negative. So I know I have a lot of great note takers. You might want to note that, use a highlighter, something to just help you remember when you're distributing a negative, be careful. Okay, so at this point in class, I would actually, oh my gosh, this cable is horrible. I would probably pause and have you try all of these, okay? So what I think I'll do is have you do that real quick, and I will come on and post another video. Obviously, I know you could just click on my next video, but I really would like for you to try these alone. The first thing you want to establish, where is the vertex of that circle? So on this one, it would be in. What's my rule? My angle is half the sum. Again, I've got a great video coming for you here in just a minute to kind of help you remember those rules. Hopefully you'll find it catchy. You'll probably find me a little weird, a little entertaining, but maybe it'll brighten your day and make fun of me a little bit. So this is vertex is out, vertex is out, vertex is on. If you look right here, on. And then I would say this is probably the most challenging problem, but go for it. I have faith in you. I'll be back. Oh, I don't know why that won't focus. There we go. I'll be back in just a little bit to work these out.